Hey everyone, how are we doing? I'm back now. There we go, fixed. Dylan says he's been working on the unit roots. Priya's got the right for the visualization decision trees. Can you look over it? I think you sent it to me, right? I can take a look over it. I'll take a look at it after class. Should be good. Or after office hours, or I might, if it's slow, we'll take a look. So Dylan is saying you run the unit root, KPPS, URCA. So the URCA package, UR KPSS stats approximation. So Dylan, you're saying, and thank you, Dylan. Good answers right here. We're gonna do a little more 201. Priya should be able to take a look. Thank you, Priya, and great work. So it looks like it's using that. Oh wait, here we go. The URC package. Oh, you haven't sent it yet? Oh. Which one do you want me to do? I'm not sure what to write, what to include in my write-up for this list. It looks weird. Can you go over it? Oh yeah, if you want me to tell me what you want to look at, we'll take a look. Thank you so much, Priya and Dylan, for being here. Let me see, is Meebot awake? I'm having that coffee crash, that second cup of coffee, which means I need a third cup. I shouldn't drink a third cup. This is a bad idea. I have the URCA package apparently, or no, do I not? So how are you saying to run the unit root test, Dylan? These three are what you have to run to dig down to the full source stuff. Oh, so you're saying run... That's crazy. Why would it do that? Why wouldn't it just give us the full blank note? Yeah. Oh, yeah. That's how you can view what's in it, is to run it without it. Why would it do that? I don't understand. I do not understand. Let's take a quick look at it. Here we go. So, the unit root KPSS. And here's where it's calling, like you said, this. Oh, this is where it's doing the stats approximation. So, package require package URCA. Don't even know I have that package. I mean, I have apparently. The p-value is stored as stats approximation result of the test as numeric, second argument. And it stores the value, so it's running this. And then concatenates, putting them into a vector right there. So, let's take this. So it's running stats approximation. I never run approx from the stat package. Interpolation function. Return a list of points where... And when you get to URC, you actually get to the C value stuff. Yeah, it's... the result of the C value. Yeah, what doesn't it just give us the P value? It's weird. I don't like it. I wish we could calculate it. Let's take a look. We're going to try to solve this mystery. Dylan, a little jazzy, energizing music right here. And Priya, send me your output on Discord if you can. Or I think we're on Discord together, right? How to find p-value. Just trying to find the p-value here. Statistical test check for the stationary time series. Looks like somewhere right here. Oh, they're doing it via this is Python. No more Python. Well. Yeah. It's rather... It's annoying. Just show me. I think The Rock knows. You emailed it. Awesome. Priya, I'll take a look. I'll go to the main screen here and take a look in a moment. I think the problem is they're just saying it doesn't matter. When we update games, I'll do it this weekend. Great question, Lane. Good question. Thank you, Lane, for asking. 100 points right there. This weekend I'll be updating it because I'll go through because it's by Friday night. So you'll see the update with the taking the exam early. So thank you for everyone filling it out right there. So that way, if you have a flight or if you have a conflict, you're welcome. Yeah, thank you for asking. If you get a chance to go over some probability problems, yeah, sure. Which ones are you wanting, Terracita? Let me know, and we'll check them out. Because those arguments in the URCA, the package right there, is what generates. So that's what generates the C value right there. So it's the KPSS should just be from a distribution. It's weird to me that you cannot just get it. So, wait. The finite sample distribution of the KPSS. Let me try one more thing here. Is there not a KPSS distribution? I got one more shot at this right here. Where mu and tau are. Oh, so it has a mu and tau parameter. So can we draw the distribution with a mu and tau? So we would have to know the parameters for the distributions. Just in the morning, Priya. Good question, Priya. And yeah, so Dylan, we might be able to do it because if we know the statistic, literally it boils down to if we know the parameters of the distribution, it becomes a stat to a 1 problem. And then we'd be looking at something more extreme, and it's probably more of a chi-squared F-type distribution. If you run the URC, UR, KPSS, it's a big mystery right here. But once again, I do want to point this out. The big thing we're finding out, and this is a little, I should mark this part of the video. So this right here has been, how about the 2 minute, this is BA's 475 KPS mystery unit roots. So we're talking about the results of the output right here for anyone wondering. And what we're getting for the output is we're getting the following. Now, Dylan, what does this output tell you? We'll end the mystery with this, and then we're going to hop over and I'm going to look at Priya's result right here, and then we'll do some probability problems. Terracita, let us know which probability problems we'll do. If you want reviewed certain things, we'll do it, and you got it. But what does that output tell us right here, Dylan? What is the interpretation of this result? I first looked at the practice problem. Oh, yeah, I'll do practice problem. Let me put that on here. So what is the interpretation of that result there, Dylan? And we're going to look at Priya's thing next. I'll give some advice here, Priya, in a second. And then we'll do Terracita's next. Practice problem 1. I looked at the first question on the practice exam. Practice exam question 1. The point 1 means that it is not statistically significant, which means that it is stationary and non-seasonal. Kind of. That's basically the right answer. So 100 points there, Dylan. It would mean technically we do not have evidence of non-stationary and seasonal data. We would continue to believe, yeah, ask some 320 questions. We'll throw them in here. We're talking a little 475 to start right now. And we do have p-values. So Kayla, this is a lot like what we've been doing with check regression. And so if you take time series right here, with time series, would this p-value up here of 0.1 for a model on conditions, and we'll end off on this, would that p-value right there, if we make a model and we check conditions, would the p-value for the condition be good or bad on a check regression? Would this p-value that is high, like when we run this unit test right here, would this p-value here and this one's that is high be good or bad? Some residuals right there. Oh, let's take a look, Dylan. Definitely. And this is just a mystery, but here's what we need to know. So to Kayla, for review, it'd be good If it was, it'd be better if it was higher, right? But it is good. Oh no, it's losing me too. Yeah, I'll have to take a look because at this point, the biggest thing to know, and Kayla's pointing it out right here, is that the p-value is above 0.05, so it's good. Does that make sense? I don't know. Yeah, Dylan, Discord it to me. We'll take a look, and hopefully, and anyone who's watching this from 475 or 320, this is a test to see if there's a problem, with the null hypothesis being that the data is stationary and non-seasonal. So we do not reject the null hypothesis. We do not have evidence of a problem, i.e. non-stationary data and seasonal data. And that's why when we do this right here, the unit differences that we would do come back as what, Dylan? When I run this, since there's not a problem, the unit root differences it suggests are what? So Dylan, last question of the day right here for this. And then I'm going to check Priya's thing out. The unit root differences, since there's not a problem, will come back as what? The unit root differences will come back as what? Since there's not a problem and we don't need it, it'll come back as 0. Yep. And so that's good to know right here is that there's not a problem. So we don't, hey, Kayla, great job. So we don't need to do it. It doesn't matter.
It doesn't matter.
So that's not a p-value right there. That is how much unit root differencing we're doing. And since there's not an issue, we don't need to do it. So if this were to come back, and we saw this with the previous data, we've got the Google data right here. So if we run the Google data through this, which the Google data is the close, the Google data comes back with a significant unit root. And since there's a significant p-value on the unit root, it comes back telling us to do unit root differences of 1. So it could depend if there's a better unit root difference. Review of unit root differencing. Let's head back here to the main screen. Good overlap between classes. Huge thank you to everybody. Let me see. Priya got the email right here. Could you please look over? Let me see. Yep, that looks right. Check to see what. So Priya, check to see what you're excluding. Only exclude variables that have more are identifiers or have more than 10 levels. Only exclude variables that have identifiers or more than 10 levels. That's my first comment. So only exclude things that are identifiers that have more than 10 or more levels. I have to zoom in. I'm blind. Oh my gosh, it's so crazy long. Okay, I have to download it. 2 seconds. The preview is blurry. Let me fix this. Download. Okay, let me take a look right here. Failed to download. No. Stop all the downloading. Okay, let me see. We're gonna do some questions. We'll do Terracia. We're gonna do your question next here. So, thank you everybody. Okay. Wow, that's very close. Yes. The second thing is correct. Priya, your first paragraph. Check to see what variables you're removing. So make sure. Well, I mean, you're right about removing Greek life because it's a predictor. It just won't be used. Oh yeah, I see what you're saying. Okay, I stand corrected, Priya. I guess you could say that maybe remove out the Q8 thing because it's just kind of considered. But Priya, 100 points right there. I misread. I see what you're saying, and great work right there about you're not using the X variable as a predictor also. So great work, Priya. Excellent work. We're going to do a little bit of test 2, and then we're going to come back to the morning questions. So practice question. So a great way to get to the practice exam is to type in the chat review 2. Yeah, I would take that out. You should be fine. If the grader takes out points, let me know. But that's great work, Priya. It looks excellent. You have the leaf report. You have the tree. But great work. 100 points again. It's just kind of... It's not like it's wrong. It's kind of like we wouldn't put it in there because it's an X. So it couldn't be used. But you're kind of right. You're kind of right. So great work. Here we go with the question. Okay, we're going to look at the practice test. Now, Mubot has put in the chat the link. It says go here for review test 2. So check out review page 2 right here, and we're going to go to the practice test. Let's open it up right here. We're going to take a picture of the first problem on the test. So one thing I want to point out is, and great job, Priya. Yeah, thank you. You're welcome. Is we have the formula sheet. On the formula sheet, what are you seeing right here? For any, so Teresita, other people watching in 201 right here, this is the formula sheet you can print off or write down. You're not allowed to have additional notes on it. So if you write it down, make sure it's very clear when you hold it up that it just has what is given to you, i.e. this formula sheet. Don't write additional notes on it. Like it is the formula sheet. So what are these? It says the probability of A or B. So you don't even need to memorize these because this is the what rule. What is this rule called right here? It's if you remember the name of the rule, you can remember it by this. What is the name of this rule? Yeah, Q2B, definitely, Kayla. We got more than enough time. Drop those questions in the chat. Here, we'll do it next right here. We've got a list of stuff from the morning. BS320, Q2B, assignment 8. So what is the name of this rule called right here? What is the name of that rule? Oh, no worries. This is called the addition rule. This is called the addition rule, and they need to be disjoint or mutually exclusive. So mutually exclusive means the same as disjoint. So what do you think this rule is called down here? That rule on the bottom, which requires things to be independent. Yeah, ask about the visualization. Sure, T, ask away. So what do you think this rule is called down here on the bottom? And you get this sheet. That's why I'm pointing out, like, it's very important to know what these things are. It says the probability of A and B is found by doing probability of A times B. So what's the name of the rule called? The multiplication rule, great practice, and then it's required that they are independent. Independent means that if A happens, it tells you nothing about B. Is snow and the temperature outside, are they independent or not independent? Like, it's 32 degrees outside, it's snowing. Are those independent things? What would you say that? It's snowing outside, it's 32 degrees. Are those independent or not independent? You can say dependent, but I like to say independent, not independent. So are those independent or not independent? They're not independent. Correct, Priya. Great job. Because snow, and great job, Kayla, right there. Excellent work. Good practice. A lot of these things are used throughout all of our classes, and I bet you law uses some logic and theory. So not independent because snow would depend on the temperature. Because let's say I tell you in any day in Knoxville, there's a 2% probability of snow. Any day of the year, 2% probability of snow. But today in Knoxville, it's 90 degrees. Would the probability of snow still be 2% if it's 90 degrees in Knoxville? So I tell you, any day in Knoxville, 2% probability of snow. School budget? You bet. And what would you say to me about the probability of snow? What would you say to me? You would say, putting school budget on here, if it's 98 degrees, then the probability of snow would go to 0, basically. Does that make sense? Because the probability of snow depends on the temperature. So even if we say any day in Knoxville has a 2% probability of snow, it's pretty high, right? You see how the lies. So now the probability of snow would drop to 0 because it can't snow because of the temperature. The probability of snow actually depends on temperature. Does that make sense to say it depends on it? Is snow and 90 degrees in Knoxville, are those disjoint events? So really quick review. We're just reviewing some ideas right here, and then we're going to do the questions. Is snow and 90 degrees in Knoxville, are those disjoint events? So we have the probability of snow and the probability of 90 degrees in Knoxville. Are those disjoint events? So you'd have to ask it this way. Let's say it snows in Knoxville. Can it be 90 degrees? Or let's say it's 90 degrees. Can it snow? And what does disjoint / mutually exclusive mean? Are these disjoint mutually exclusive? But they are. Don't worry, Tercia. This is a good review. So what disjoint / mutually exclusive means... Oh, in Knoxville, correct. Snow in Knoxville. 90 degrees in Knoxville, snow in Knoxville. These are disjoint. Because if it snows in Knoxville, it can't be 90 degrees. Does that make sense? It's like, Kayla, great work, great practice right there. If it snows in Knoxville, it can't be 90 degrees. If it's 90 degrees in Knoxville, it can't snow in Knoxville. Oh, did I ask? Oh, I'm sorry about that. So these are, and they're similar words. They're the same thing. They are disjoint, i.e. mutually exclusive. Does that make sense? I'm going to switch the question by accident. So these would be disjoint, mutually exclusive events. If one happens, the other can't happen. And so let's look at our questions right here and remember these rules when we go to the practice problems right here. Good practice for stuff. Okay. Okay. We're going to copy the questions. We got a lot of good questions in the chat. Thank you so much, chat. Here we go. The first question says, you have a fair coin, two-sided. If the first three flips, yeah, practice exam, let's go. If the first three coin flips come up tails, what is the probability of the fourth coin flip coming up tails? So you just had the following occur. Tails, tails, tails. What is the probability of the fourth flip coming up tails? You don't know this one yet. What is the probability the fourth one will come up tails? Everyone's saying, hey, in the chat, love it. Who knows the answer to this one? Then we'll mention what. Great job, Kayla. It is still just 50%. Because it's simply the past events are what of the current events. Coin flips are great examples that this coin flip, Rock knows.
It doesn't matter.
Each coin flip is what of previous coin flips. Each coin flip is what of the previous coin flips. Think of the words we were just practicing. Each coin flip would be what of the previous coin flips. Good way to practice words. Because they're independent. Exactly. So the probability right here,
It doesn't matter.
it doesn't matter that it already came up tails, tails, tails. It's still 50%. And this is also known as things like gambler's fallacy or law of averages, which is a fallacy where people think that past events will influence current events. What is the probability of getting 5 tails in a row? Now, this is a different question, not like the fifth coin flip being a tails. It's you get tails, and then you get tails. Instead of writing and, like you get tails, and then you get tails, and then you get tails, what should I maybe put here instead? But would it be... well, they are independent. Great job, Teresita. It is 50%, and it's because they're independent. So this is the answer to the first question right here. It is 50% because they are independent. And with the second question, what is the probability of getting tails 5 times in a row? Like you get tails, and then you get tails. Kind of. Very close, Brendan. So Brendan right there, you could do it that way. And Kayla and both Brendan are suggesting that we change this to a multiply. So now we want to find out the probability of tails. Tails, tails. What is the probability of tails? Brendan, you're super close. Great job, Teresita. Excellent points. 100 points right there. Perry is pointing out too, and great practice, everybody. It would be 0.5 times 0.5 times 0.5. And Teresita has put the shorthand in of this right here, which I believe is equal to quarter, 1.25, 1.625, oh my gosh, 0.03125. I believe, someone correct me if I'm wrong. Don't stop me now. I mean, do stop me now if I'm wrong. So is this the answer? We can check on calculator. Let's see. 2, 3, 4, 5. There we go. We're good to go. That is the probability right there. Double check your work. Do it in your head. Do it in the calculator. Make sure you've done it properly. So suppose we have 2 events right here. A has a probability of 0.3 and B has a probability of 0.5. Find the probability of A or B. Now, when we say suppose that the events are disjoint, disjoint/mutually exclusive goes with what rule? What rule? And once again, please, 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 please go to your formula sheet. Disjoint/mutually exclusive. Formula sheet's going to help you out. Goes with the what rule? Disjoint. Great job, Teresita. And do remember, you basically have a cheat sheet right here. So when people get it wrong, I'm like, no, my cheat sheet. I mean, it's not a cheat sheet. You don't have a cheat sheet. You have a formula sheet that has some answers on it. So because they're disjoint/mutually exclusive, has anyone ever seen Bully Maguire? I feel like I have his haircut lately. Like I should just cosplay as Bully Maguire, maybe with this dark t-shirt. I'll just like, I don't know, That looks really badly. Side conversations with Brian being Billy Maguire. It's a meme online. I don't know. Billy Maguire. Toby Maguire. Oh my God, what's wrong with my hair? Calm down, Brian. Gonna throw some dirt in your eye. Oh man, good stuff. Good stuff. Some Spider-Man 3. I mean, kind of. Okay, go check out the new Spider-Man movies. No spoilers. So we're using the addition rule. This can just become an and a plus right here. So assuming that they are disjoint / mutually exclusive, we can add them. So we're just going to go 0.3 plus 0.5 equals 0.8. And we're good to go on that right here. And find the probability of A and B. Once again, do remember your cheat sheet is your best friend. Bully Maguire endorsed. So right here, you can see if they're independent, we can multiply together. So what would be the answer to this question right here? Assuming it's just another world right here, another universe where you assume that these are independent, i.e. we can do this. Multiplication rule, Priya, great job. So what will the answer be as I'm solving it right here? Who's got this just for practice? What do we have right here? It should be, how does that solve? Double check your work. It's easy to make mistakes on these. Great job, Priya. Excellent work. Good work. This one is, this one gets people right here. Okay. This one was the one where I swear people made 97s on the test and they were like, why? So we see right here, C and D. As soon as you see C and D, you should ask yourself, are these two things what? Because you're actually asking this. We could put the probabilities before it. But you should say, are these two things what? Now be careful. You probably got a few words in your head, but double check. Look at your formula sheet. Independent. Oh, Kayla might remember it. Good questions right here. We're asking, are they independent? That is a sneaky one, right? So you want to ask, is it independent? So we have here two different things that could occur. We have here C, which is you are rear-ended by another vehicle. Being rear-ended by another vehicle. And we have here D, which is getting to work without having any collision. So are they independent? Great question. So C is you are rear-ended. Here's your car. Boom, rear-ended. That's you. D is you get to work without any sort of accident. Nothing happens. What does it mean if they're independent? It means if one happens, it would change the probability of the other. This is the same day. If you get rear-ended, can you get to work without getting in an accident? Yes or no? Brendan's starting to see it, I think. If you get if you get rear-ended, can you get to work without getting in an accident? If you get rear-ended by a car, can you get to work without getting in an accident? Someone's like, how did you go? I got here without an accident. They say, but I hear you got rear-ended. You're like, well, I got rear-ended and I got to work without an accident. So we're thinking like not afterwards. So Brendan, that's why the theory of this might hopefully it doesn't cause confusion. We're saying like that day, no, exactly 100 points right there, both Brendan and Kayla. So what it is getting to work without an accident would require not getting into an accident. I just said the same thing. If you get into an accident, if this occurs, like if you get into an accident, the probability of getting to work and not getting in an accident would go to what? Because this can't occur. That's the hint. Number 4 on the homework, local newspaper. Yeah, Andrew, we should be doing that here in a moment. I think it's on the list. So now the probability of not getting into an accident would go to what? Because you just got into an accident. So you can't get there without getting into an accident. The probability would go to what? And now you can't get to work without getting into an accident. You already did. So now the probability would go to what? 0. So actually, the probability is 0. So it can't occur. Does that make sense? Or you could say, since this did occur, I mean, if you know it did occur, it has to have a probability of 100%. Technically, it did occur. But we're still saying that randomly occurred. Like randomly you got into an accident. So what it is, it's a confusing thing. These two events are very, very what? Getting to work without getting in an accident, getting to work, having gotten into an accident are very what of each other. They are also this. They are two things, but specifically we want to talk about this word. They're very dependent. Exactly. And they are another thing. I don't want to assert, or they're associated, they're dependent. Like getting to work and getting in an accident would depend on if you got into an accident or didn't get into an accident. So because of this, you can't multiply them together. And theoretically speaking, they can't both happen at the same time. Like, let me ask you this. I think this will make this question 100 times easier. Who's got a favorite sports team? Tell me your favorite sports team in the chat. I bet it will make 100% sense if I use a sports analogy. Tell me your favorite sports team. Who's got a favorite sports team? I have to know another team in the league. The Giants. Giants are playing the Patriots in the Super Bowl. Oh, no, they're playing Tampa Bay. Tampa Bay. The probabilities, the Vols. Go Vols. Vols. The probabilities are listed below. So here's the same question, but a little different. The probability of the Giants win, I'll be nice, is 70%. And this is the Super Bowl, so someone has to win. There's no tying the Super Bowl. Probability Tampa Bay wins. Brady's still working hard, but he's got this. So let me ask you, think of this theoretically. What is the probability of Giants and Tampa Bay winning the Super Bowl this year? Just if you were to talk to someone and someone says, what's the probability that the Giants and Tampa Bay win Super Bowl this year? You'd say, that has a probability of this. It has probability 0. Does that make sense? Like, this is the same question, but just a different theory way of doing it. Because if the Giants win the Super Bowl, like if I told you the Giants just won the Super Bowl, would you need to ask me about Tampa Bay? They were playing Tampa Bay this year, apparently. Would you need to ask me about it? Would you need to ask me about, I say the Giants just won the Super Bowl. Would you be like, but did Tampa Bay win the Super Bowl? I'd be like, I just told you the Giants won the Super Bowl. The probability of Tampa Bay winning the Super Bowl, if Giants win the Super Bowl, would go to what? If Giants win the Super Bowl, probability of Tampa Bay winning the Super Bowl goes to what? Everyone wins in their heart. That's some of the kids would say. It'd go to 0. So this means that they both can't happen because the Tampa Bay winning the Super Bowl would what on the Giants winning the Super Bowl? Tampa Bay winning the Super Bowl, fill in the sentence, what's on the Giants winning the Super Bowl? Telling you that they're not this. Tampa Bay winning the Super Bowl, if they're playing each other, would what on the Giants winning the Super Bowl? So Tampa Bay winning the Super Bowl would what on the Giants winning the Super Bowl? They're very, very this, meaning we can't do this mathematic on it. It depends. I think this makes this question a lot easier to understand. It has to be one or the other. They're actually disjoint too. I shouldn't have said that word, but it's very dependent. Tampa Bay winning the Super Bowl depends on the Giants winning the Super Bowl. We cannot multiply them together. Good review, tougher question. Do check out the formula sheet, which goes over these and also gives you the rules for it and also has our mathematics for the probability distributions. Let us go back out to the main screen. And we've got so many great questions. Stay tuned. Lots of 201, some 320 coming up here soon. We're going to do one more 201 question. Okay, I need your vote. School, phone, bank, investment, market. Start shouting out what you want in the chat. School, phone, bank, investment, market. Then we're going to do 320 right after it. You're welcome, Teresita. We got a vote for school budget in the chat. We got a double vote for school budget. Always good to review. School budget, 3 votes. Looks like it's going to be school budget. And then we're going to do a 320. Then we're going to come back to 201. I tell you, I did an online lecture today, and it made my day. It went so well with educators. And they were talking in the chat a lot. I was so happy. Because it's you being here talking in the chat. You hear me say this all the time. But I mean it. If watching office hours when no one's here, you can see Brian's sad. It's like I don't have that energy that everyone brings right here. Can you help with the visualization? You emailed me. Definitely. I'm so glad it went over it. Were they super? Yeah. It went so well. They asked tons of questions, and people look to be getting things out of it. So T, I can take a look after this next break right here. Summer and fall, get ready. Oh, what are you taking in the summer? It went so well, Priya. It was such a fun time. And I was honored that they had me speak at it. It was really great. Just went really well. We got the school budget referendum coming right up right here. So thank you to you. It's to all the students. So T, I'll take a look at that after the next thing. I can help. Well, you can email it or email about it, or you can ask questions. We did visualizations last office hours at the end of it, and it's in a few others. But we'll take a look. Here we go. Some school budget. The code deep dive. Love it, Dylan. Dylan, thank you so much. 100 points, Dylan, helping us out with some code right there on the KPSS unit roots. So here we are with the school budget question. I am. I teach 320, 474, 475, 201, 207, 340. Trying to think what else I've taught. Am I still in a Discord? Nope. Oh, that's so awesome. I'll check that out, Kayla. Thank you so much, everybody. All right. Oh, we got a lot of stuff in the Stats 1 Discord. Whew, busy day. Okay. Let's go check out this question, school budget. Okay, if you are preparing for the test, or if you are preparing for the test, it was a good lecture. I wonder if I could send it to you, Kayla. If you are preparing for the test, what is the first thing you should do with this problem? This is what you need to know. If you're watching this and you're trying to figure out this problem, what do you need to know? You need to know the step for success is to start by doing this. So when you say in the chat, because it's going to be the first thing that goes to your mind when you see this, Priya, boom, 100 points. Label the stuff. Notation, Kayla knows right there. Kayla's done some 201. Kayla, when it comes to these last few chapters, is it all about that notation where it says they talked to 431 people? So 431 is the sample size. The true proportion of people who are going to vote for this is 52%. That means the complement of the true proportion is 48%. So over and over and over again, you have to know the notation. Now, this problem is sneaky. Could you go over the carbon monoxide? Yeah, Cassandra. Let me put that on the list right here. A little bit here. We should have enough time to get to that. I'm going to move it up a little bit because we haven't done that one this semester. So that's going to move up on the list. So that's going to be a little bit newer because we haven't done that one yet. And I usually give preference to new questions that are not in any videos this semester yet. So I've put that about 2 things away. So thank you, Cassandra. So with this one right here, we are going to see, is this poll going to be predicted to be defeated? If we were to poll people and we ask, do you support this measure? If we predicted defeat, less than this % of people would have voted for it in our sample. So the question is, less than what % in our sample would need to be seen if we predict defeat for something? So I'm saying, I think this will be defeated. In my sample, I saw less than this % of people voting for it. So in my sample, I saw less than this % of people voting for it. I predict this will be defeated when it goes to be voted on. In my sample, what would I have to see? Oh, Priya's already getting some of the... Great job, Priya, right there. Less than 50%. Great job, William. So P hat, we're looking for actually technically a P hat less than 50%. Now, I think the hardest thing about this chapter is the theoretical components to it. Because we're asking, theoretically speaking, what would happen if this newspaper took a poll of 431 people? Well, the average thing to see are the expected value of a sample proportion. So that says expected value of sample proportion. You don't multiply them. It's just read as a statement. I expect a sample proportion to be what? Who knows what it would be? This is the easy one. Like, if 52% of people are going to vote for this, like that's the truth up there. 52% of people are going to vote for this, so I'd expect to see what? Awesome. Play some with some plants. Good to see you later, Dylan. And swing by the 201 Kahoot Sunday night. If 52% of people are going to vote for this, then what would we expect to see? If 52% of people are going to vote for this, then I would expect to see. Oh, and I'll explain that one. Pretty good question. Because they're asking predict defeat. So what is the probability? They would have to see a sample proportion. So if they went out and spoke to people, they would have to see a sample proportion less than 50%. Yeah, thank you so much, Kayla. Good question. Good advice. Yep. And great advice, Kayla. That is a huge help. Definitely doing the searches. You can find so many videos on so many things. That's if someone usually asks, like, hey, I'm stuck on this problem, usually I'll send them a video because it's harder over email or Discord even to go back and forth usually. And then if they're stuck, they'll say, like, I didn't understand this part, and then we can go into detail. So Kayla, that's worth some 500 points. And I think Brendan's pointing out too, that's a big help. Especially if you are watching this and you're not finding what you need, there's usually a video on it, but we do try to do as much as we can here live. Priya, does this make sense about this right here? That this is saying if they saw in a sample less than 50% of people voting for it, the newspaper would say, it seems like the measure's not going to pass. Does that make sense theoretically? So that says in a sample, they saw less than 50% of people voting for it. And the question alludes to it right here. Predicting defeat would mean in a sample, they saw less than 50% voting for it. And that's in a sample of like 431. So if they observed that when they took a sample of random people, because 50%, like, good question. So like 50% would be like, imagine if I say, okay, we're either going to have pepperoni pizza or mushroom pizza. So go ahead and I want you to vote on pep pizza or mushroom pizza and take a vote in the chat. Are we having pepperoni pizza or mushroom pizza? I could have voted yes or no on it. Pepperoni pizza. I didn't know it's about pepperoni. So which of the measures is going to win right here? The pepperoni pizza. Ooh. I like some mushroom. Get some good mushrooms, some portobello. Maybe I should have said glazed, balsamic glazed portobello mushroom pizza with a basil. What am I trying to say? Pesto basil base infused with garlic in the crust and cheese crust, stuffed cheese crust pizza with feta. Brendan, that is I think Brendan rightfully points out Brian is trying to give some response bias, the way in which the surveyor asked the question. Another 500 points. Wait, wrong mushroom. So the pepperoni pizza measure 1, Priya, does that make sense? The pepperoni pizza measure 1. And so if the people are voting yes or no for a measure and they see less than 50% vote for it, the measure will not pass. Does that make sense? So the pepperoni pizza measure passed right here. If it was like, should we have pepperoni pizza? Yes. Mushroom pizza? No. The pepperoni pizza passed because it got more than 50%. The pepperoni pizza measure would have failed if less than 50% of people had voted for it. So if you think about it as a yes-no referendum, if less than 50% of people are voting for it, then it would fail. So the newspaper will predict defeat if in the sample less than 50%, because it's only exactly. So they're voting yes or no. Exactly. Maybe I should have done a yes or no vote. Like, should Brian give everybody A's? Vote yes or no in the chat. Should Brian just give everybody A's? Apparently UCLA posted a professorial position. I don't know if this is an April Fool's joke, because it certainly sounds like to me, where they weren't going to pay you. It was like biochemistry or something. Did anyone else read about this? They apparently they had a position that was not paid, and you know what, Brendan, I would have taken that. I would have taken that. See, they're gonna get that kind of grammar if they. I'd have said, sure, I'll take the job, and they say, really? I say, yep, and then I just go in and say, here's an A. I say, they're not paying me. Everybody gets A's. My job here is done. You get what you pay for. And you didn't pay me anything, so I'm not doing any extra work for you. I don't know, that's mean of me. I mean, it's mean of them. I don't think that's good for the ecosystem of teaching. Someone who's worked that hard to be educated and is going to work hard with students should be compensated. My favorite Southerner saying is, yep. Imagine if you just sign up for the course and you get an A. So that measure passed right there. So to Priya's question, that measure passed right there with 85% of the votes. Someone here said no. I just got here. Can you explain the problem again? So we're trying to see if a measure will pass. Braden, great question right there. Braden, a local newspaper is polling people to see if the measure will pass. A school referendum is going to be from this local town. And if in their sample they see less than 50% voting for it, they will predict defeat. Now, right here, the truth is 52% of people are going to vote for it. So what is the most likely thing for them to see if they sample from this? So these are all the possibilities that could occur. What should be at the center of possibilities for them? Because the truth is 52% are going to vote for it. So what should be at the center of possibilities for them? Because the truth is 50. Apparently, somehow we know the truth. I know that seems weird because you wouldn't know that. Apparently, we know the truth is 52%. So if they take a sample, great job, Priya, right there. It's likely they'll see 52%. Not meaning they will. Great job, Teresita, also. 52% because that is the what of the distribution. 52% is the center, the mean of the distribution. It's what we expect to see. It's not what we will see. It's what we expect to see. So what else do we need for a distribution? We also need a standard deviation. And the standard deviation is the p times q over n square root. P times q over n squared. Please stop me if you don't know how I got q. Q is 1 minus p. So we're going to find the standard deviation. P times q, do it correctly, over n square root. And the standard deviation is point. Great job, Priya. 100 points again. Excellent work, Priya. And there's the standard deviation. Now, what's interesting about this is we are wondering about, why am I writing this number right here? Where's my color coding? Why did I write 0.0496? That is correct. Why did I write 0.0496? Why did I write 0.0496? Why did I do that? How did I know that number? Correct. I subtracted. Great job, Priya and Teresi. It's one standard deviation, which is true. It's one standard deviation below. And so now we're wondering about this. And so now we want to go here and do the following. Go here. Who has a guess? You'd be amazed at how good your guesses might be. Does anyone know what the area is below -1? This is, a lot of people say, well, how would you test us on the test? The test could give answers like 5%, 10%, 15%, 18%. Not 40-ish. Good guess there. Good guess. So below -1, yeah, Cassie, we probably have enough time. We got enough. We're going for a good bit more. So, Cassie, feel free to ask. We got a good bit on the list. We're doing it 320 for this. You'd probably guess it's around 18%. My drawing might not be perfect. Below this is 16% according to the empirical rule. So a good guess might be 18%. If these were the answers, the only one possible is 18%, because below here is 18, so that has to be a little bit bigger, or 16, excuse me. But what we need to do now is we need to go to the David M. Lane and draw a picture that looks just like this. So let's go to the David M. Lane and draw a picture that looks identical to it. So here we are on the David M. Lane site. We're going to enter in the mean of the distribution, which was 0.52. And then we enter in the standard deviation. And then we go below 50%. And there it is right there. It's actually 20%. Oh, Priya, did you know the answer? Or Teresita? Great work. It's actually 20. My guess of 18 was kind of close. Teresita might have solved it there. It's basically 20%. But then I want to ask you this. Wait, what would you do? We would give you things where you'd have to know theoretically. Because below this number right here is basically 16%, very close to it. So I knew that because of the empirical rule. So then I could say it has to be a little bit more than 16%. And so we could ask you, like, theoretically on the test. So, Teresita, if you had guessed 20% for that, I'm thinking, oh, really? Hopefully I didn't do another error on it. Teresita, I thought you had it. Really? Is it that little? Wow, you'd almost had it. Investment website? I think so. I think it's on the list. It is on the list. I'm going to move it up right here. We've got carbon monoxide. Here we go. Carbon monoxide. That is a few away. And let me move carbon monoxide up. There we go. Yeah, I think we'll have just enough time. We're going to do a little 320 right here next. So stay tuned if you're 201. We'll be coming back to these questions in just a moment here. Okay, it's time for a little 320. That's sad. Oh, no. What's sad? I put the wrong time. Oh, school budget went wrong. What's sad? No. Q2B. Not 2B. Q2B. Ooh. I'm on the activity, I think. Oh, you were close? Teresita, 500 points. Yeah, if you got... I thought you would have had it too. I really thought you had it. I thought you had the answer. I was like, that's close. Okay. You're welcome, Priya. Great job, Teresita and Priya. And everybody in the chat. Okay. 52 Q2B. Sometimes my jokes are low level, sometimes they're high level. You never know. Here we go over to the main screen. Let's do it. Okay. So this is BAS 320. We're doing some interactions right here on whether the strength of a relationship depends on another variable. Sometimes the strength of a relationship of like demand might depend on average temperature, on average wind speed, and these variables might explain demand in different ways based on the other variable. Fit a model with all two-way interactions for the bike dataset and use C interactions to scan for possible interactions. Add the argument many equals true or there will be too many plots. Does it look like we should include interactions in the model? Why or why not? It's a great question. So once again, I love it. We were talking about this earlier today. We're using the bike data set. Make sure you have it loaded up. Boop. Now the bike data set's loaded up. I clicked the load all chunks above button, which loaded all the chunks above. And we're going to take the bike data set and make a linear model, LM. We're going to predict demand. And Kayla, how do we get all two-way interactions? What is the code for all two-way interactions? You're welcome, Teresita. And so what is the code for all two-way interactions? Every single two-way interaction. So here's every X. That's every X. Then how do we do every combination of like the X1 times the X2, plus good guess there, Brendan. If we do average temp plus like effective average temp, that'll add them in. So you can do plus. And if we want to do all two interactions, we do the following. We go dot raised to second. Yeah. So does that make sense? This is doing, what I do? I don't even know how to do it. No data. I typed 8. Okay, so there it is right there. And this is how the output looks. Now, if you notice, this output looks, I know. Does this output look like anything you've seen over here in Jump? For my 320s, 201 students, excuse me. Does this output look like anything you've seen over here in Jump? This output over here with an estimate, a standard error, a t-value, and a p-value. Wait a minute. So this is the crossover between classes. It's the same output for the parameter estimates with an intercept for the model, also with the p-values of each thing in the model. So what is the quick way, Kayla, to see if any of these interactions are statistically significant? And this is where the interactions are right here. These are the terms without the interactions, like average temp, effective average temp, average humidity, average wind speed. What is the quickest way to see if things are statistically significant? What is the quickest way in that output to be like, oh, or oh? The stars, exactly. And technically any star. Correct. Great job, Brendan, right there. And Jump actually does the same thing. Jump will include a star when something is statistically significant, or it'll color code it. R uses star codes, and as long as there is a star, it is statistically significant. So you can see right here, it just means the value of the p-value is between these. So you could look and be like super significant, significant, significant. And is there at least one statistically significant interaction here? And rather, we could also look at that. So, yep, that's what it means. It's just the easy way to know the p-value is super small. So are there statistically significant interactions right here? Are there statistically significant interactions? Are there statistically significant interactions? Bully McGuire today. He's going to dress up as him for Halloween. There are. Brendan acing it right there because we see p-values for interactions below 0.05. Now, Brendan, do you like bacon or not like bacon? Kayla knows where this is going. Brendan, do you like bacon or not like bacon? Oh, there was 2. I think there was 2. I'll go and look at it in a second, Kayla. You got it right. There's 2. Brendan, do you like bacon or not like bacon? What do you think on bacon, Brendan? Kayla knows where this is going. Pro bacon. I'm gonna give you a cheeseburger, and then I'm gonna say, but wait. Here's some like fresh like bacon, like it's just sizzling. It's gonna melt the cheese more. What's your thoughts on that? The cheeseburger, you give it a 7 rating, and then we put some awesome bacon on it. I've got it here, and you just open the cheeseburger, put it on. It's got bacon. I'm just talking like thick cut, applewood bacon, maple glazed on like a big cheddar burger. I'm starving too. I say that's amazing. And then when you say easy 10 right there. Well, you love bacon so much. I know you're not a big fan of toothpaste. I'm going to take some of that extra bacon I have and chop it up real good, Brendan. I'm going to put that bacon in your toothpaste. Scott's got weird. Brendan, how do you feel about that bacon in your toothpaste? Now, you're very pro bacon, but we've got the no bacon toothpaste. You give it a 5. It's kind of meh. And then we put bacon in the toothpaste. No, what are you doing? Would you say to me, the way in which bacon impacts our liking of something depends on what it is? Like, bacon's generally pretty good, at least in my view. Maybe some turkey bacon or some faux bacon for people. You put bacon in macaroni and cheese, awesome. You put bacon in Jell-O, what are you doing? So it really depends on what we put the bacon in. It's mostly good, at least in my view. But there's an interaction on how it does it. It's kind of codependent, or it interacts, right? Sometimes it really enhances something. Sometimes it doesn't do so well. So remember how these lines look, because this is going to help us for the next question. Let's take a look at the C interactions on this plot. And go here to the model and do many equals true. Now tell me, oh, bummer, 2 seconds. It's not pretty. I'm going to make it pretty. Don't look. Don't look. Oh, man. Okay. How do these lines look? Do they look parallel or not parallel? And this will go to Kale's question right here. How do these lines look here? Do they look parallel or not parallel? How do these lines look? Parallel or not parallel? What are your thoughts on these lines? Parallel or not parallel? And parallel means this. Not parallel means this. These lines look parallel or not parallel? Not parallel. This, if you can see it over there, is this is the interaction we have between average temp and effective average temp. They look pretty perpendicular, right? So does average temperature increase demand, or does average temperature decrease demand? So here's the key word you need to know, and it's a D word. Be careful on this. Does average temperature increase demand, or does average temperature decrease demand? So this is average temperature on the x-axis, and here's a line with this, and here's a line with this. So if you know what interactions are, you would say, well, it what? What are your thoughts? This is a trick question. Because if you know what interactions, you'd say, well, average temperature, this is. So what do we say right here? There's a very significant, both is true. 100 points right there. Both is true because it would really depend on the effective average temperature. If the effective average temperature is small, so what the line on the chart means are the implicit lines, which shows us when effective average temperature is small, average temperature would increase demand when it's higher. But as effective temperature goes up, average temperature starts to have a kind of not so strong relationship, and eventually average temperature has a negative relationship for large values of effective temperature. Does that make sense, Brendan? This is a big concept right here, and let me know if you have questions on it. But the way in which average temperature explains demand depends on effective average temperature because of the strong interaction. So if we wanted to say, well, is average temperature going to exactly, it's changing it. It's there's actually infinite lines between this. It would go because it's just showing us 3 points of time right here for like a small value, a medium value, and a large value. And the impact of average temperature depends on effective average temperature. So we can't really tell you what average temperature does until we know what effective average temperature does. This was a very, very significant interaction. Now, the next one is not significant. You expect the lines for a not significant interaction to look more this. Not significant means, Rock knows,
It doesn't matter.
it's not going to matter what the other variable is. So the lines should look more this. So when the interactions are less significant, the lines should look more this. Now, they won't be perfectly this unless the p-value is 1. We talked about that theory yesterday. But the less significant, the more this the lines are. The less significant, the more this. You're kind of right, not necessarily flat, because it could be that X1 has a relationship. Go back to the original idea. You're on the right track. 100 points. Good work right here. There'll be more what? And they're kind of this. There'll be more parallel. It's not perfectly parallel. Well, that was decently. There'll be more parallel. We're getting so many interactions. There'll be more parallel. If you see these, they're more parallel. The weaker the interactions, the more parallel the lines are. I wish there was a super weak interaction, but the weaker the interactions, the more parallel they are. The stronger the interactions with this is our strongest. So if they're weaker, they're more parallel, which I know those aren't perfectly parallel, but these are like, if I told you those lines are parallel, you would just be like, haha, yeah, right. If I took a snapshot of this and only showed you this, and I said I tried to draw parallel lines and showed you this, you'd be like, you didn't do great. But if I show you this over here, if I take the same snapshot of time, these are ridiculously not parallel. Those are ridiculous. No worries, Kayla. So I think this does it right here. We were looking at the plots. Let me know if you have questions. Once again, kids come first. Don't worry about that. We've done 2B. Write out the overall regression equation around each. Wait, we're not writing that all out, are we? Well, that's 3. That's 3. I was like, we're not writing this whole equation. It's a lot to write. I think that's got it. Does it look like we should include interactions? So let me just answer it this way, Kayla. Some of the interactions are statistically significant. Do you think we should include interactions? Yes or no, Kayla? Going back to the main question right here, a little lecture on interactions. Some of the interactions are statistically significant, i.e. this one and this one. Do you think we should include interactions in the model? Because statistically significant means that in the multiple model, they bring with them new information not accounted for by the other x's. So do you think we should include interactions? I.e., we have 2 statistically significant interactions. Do you think we should include them? Boom, Kayla, you got it. You're right. I think we should include them too. Yes, because they're statistically significant. They bring with them new information. Great job, Brendan, right there. That means that they help explain demand. They reduce the sums of squares in a significant way that is unlikely by random chance. Stats person. If you're non-stats, you would just say, they help us. They're good variables. Should we include the significant ones? We could also include... That becomes a debate right there, Kayla. So the answer to it would be we shouldn't at least consider including interactions to some degree, definitely the significant ones, and the other ones are a conversation. We'll talk to them. We'll do some looking around, but we should be considering interactions to some degree. Great job, Brendan. Excellent work. See you in class. Brendan, I'm giving a huge shout out to Brendan right here, doing some 320, not even in the 320 class. We're throwing some 500 points for Brendan right here. Hopefully he was here to get it. Thank you, Brendan. And thank you, Kayla. As everyone knows, I just love having people here to talk to and go through the assignments with. And don't worry, once again, kids do come first. That's like number one. Cooking and everything. I always love it. So, Kayla, one of my favorite things is when a 2-1 student is like talking some 320. I think, is he 320? Oh, it's been a long day. I think you're right. Taking back those 500 points. Taking back those points. I think we have a carbon monoxide question coming up here next. All the points are back. That's why I said see you in class. I was like, well, yeah, next week. Oh. Gonna wake up. Whew. Carbon monoxide question. Where is it? Preview. Okay. I was like, I know him. I know I saw you say hi, and I was like, oh, Kayla knows someone in the... I saw at the start there. I was like, oh, she knows someone in the 2-on class. Oh, wait. Wait, what? I clicked the wrong assignment. I might go eat some awake chocolate. I can get chocolate and caffeine at the same time, like a double dose. Good stuff. Okay, so I got the question loaded up. Brian's going to go eat some awake chocolate here in a little bit. Good snack, good caffeine, good energy. Okay, so we're getting the Tom stamp. Here we go. Let's go do it. Time to do it. Okay, so we got the carbon monoxide question right here. And with this question, we are going to draw the sampling distribution of the sample mean. Now, if you've been doing these questions, homemade enchiladas. Oh, Kayla, that sounds awesome. If you've been doing these questions, then you know the first step we're always going to do. If you get to a question on the test that you're doing any sort of probabilities or sampling distributions, mark your notation. Take a moment right here if you're working this problem and try to mark it before I do. Did you do it? Yay! Points. This is Brian trying to counterbalance his lack of caffeine. He will inject caffeine straight into his mind. Don't do that. And so there we go. Oh, we got one more. Missed you right there. So we need to take here and write the equations. Now, these are on the formula sheets. So if you identify what this chapter is from, you can go to the formula sheet down here and see we're doing the sampling distribution of the sample mean. Have a great dinner. Enjoy. We're going to use mu y hat, mu y bar. The sampling, the mean for the distribution of the sample mean is equal to the mean, and the standard deviation for the sample mean is equal to the standard deviation of the square root of n. And this is how to get the z-score. We do talk about this a little bit here, but it's the observation minus the mean of the distribution or the standard deviation. And so now we need to know what we have. Remember, we just saw the equations, but it's going to help us to mark the notation. Well, it says that this is the mean. The mean is going to be the actual mean. That's not the mean for the distribution of the sample mean yet. It's just the actual mean. This is going to be the standard deviation, which is the actual true standard deviation. This is the sample size we're taking right here. And then we can use these for mu y bar. That's a sigma. Mu y bar equals to mu, which is just as easy as it sounds. If we expect on average for these cars to have this much carbon monoxide output, well, then what we should probably see on average for 70 cars. It's like saying if I expect the average person to be 5'7", I talk to 70 people, I'd expect them to be on average 5'7". It's the expected mean for a sample. And now we have the standard deviation next, and the standard deviation of y bar is equal to sigma over square root of n. I actually forgot to do square root of n when I was in school, and I didn't get all the points on the question. So don't forget that. And so then we do square root of 70 right here, making it smaller by the degree of the sample size, square rooting it. And so now, let's take and do 70. Point. Oh, my brain's breaking. I was going to solve it, and then my brain said, nope. What am I doing? Wake up. There we go. Point 0956. Sorry, probably just made someone yawn. There we go. That is the standard deviation. Now, on the test, you would probably be drawing this out. That's a good way to find answers a lot of times is to draw it out. You'd go down here, draw your sampling distribution, put the mean at the center, 3.796, and start going up the units of the standard deviation and down the unit of the standard deviation. And this is the units by which you will go up. And then I would mark my z-scores. So we luckily don't have to do this right now. We can go over to the David M. Lane And once again, if you're on the test, I'd probably be writing it out and drawing it out to see where we're at. The David M. Lane is just going to be an easier way to get everything drawn for us. So we're going to put in our standard deviation. In the standard deviation, we're going to take our mean of the distribution, 3.796. 3.796. If you notice, it's putting those numbers in that I was talking about, where we're going up 1, 2, 3 standard deviations. So the first question is asking about the shape of the distribution. Well, we've drawn the normal curve because it meets the central limit theorem. Hopefully, these are randomly selected cars, less than 10% of all cars that exist. And also, the shape is only a little bit skewed, I believe. And with that, this should be a large enough sample size. So it says to 3 decimals. There we go. And the mean of the distribution is 3.796. And let's check the answer. Good deal. And now we want the probability between 3.9 and 4.1. So when we do this right here, we need to have our David M. Lane drawn because we're going to go between and 3.9. I've got the wrong one. That was from earlier. 3.9 is about right here, and 4.1 is off the curve. We could guess this. 3.9 is right there, so I'm having a feeling that we can figure this out to 3 decimals. Oh, we get one more guess. No, that was close. 3.9 to 4.1. Let's find it. So we want to go between 3.9 to 4.1. It's going to be like 14.8. Oh, I was further off than I thought. Well, that was sad. Much further out than I thought. So round to 3 decimals right there. Final check. Got worried. Okay. The next one says the top 10%. So the top 10% is actually going to be somewhere about, it's going to be at 1.28. So it's going to be right about here-ish. And we can do this also by going over here, typing in 3.796, and I'm on the second applet, and doing this right here, about 3.9 or so, 3.91. There it is, 3.919. Now it asks us to only round to 1 digit, so, and remember we said it's right about there. It's the top 10%. It does say top 10%, right? And greater than value. Good to see you here, Jack. Some point hype. Oh yeah, Jack, did you come up with that? I'm trying to remember. And round to 1 decimal, we're good to go. That's got it. Awesome points. It's points. Nice, Jack. We've got new stuff, Jack. Check it out. Vols or UT. Mubot's got a lot of new things in his arsenal to talk to people. You don't even have to do the exclamation point. Mubot's got a lot of new things he can say. We'll head back to the main screen. Thank you, Jack. 100 points. Good seeing you here. I love a lot of different things we have and we can check out. But good to see you here. Brian's trying to wake up with that coffee. We got investment website, phone survey, carbon monoxide. Oh, we just did carbon monoxide. What are people's votes? We probably have time for at least one more. If you want right now to do the investment website, phone survey, bank loans, or marketing question, let me know. We've got time for at least one more of those. What are people's thoughts? This is all chapter 13, so let me get it pulled up right here. But let me know. Jack with all those points still. Great job, Jack. You're at Kayla level now. So what would people like to do? It is your call. We'll try to do one off the list since people asked about those. And they are in other videos. If you're like, oh no, I didn't hear the question. Didn't get to see the question. They are in the other videos. And if you're stuck, let me know. I'll send them your way. But it's always good to do them live. We'll do... Oh, I need to send out the announcement to class. Let me get that out. Send out the announcement. The wall. Take a nap. It'll be nap time. I remember nap time when I was a kid. Like in school. You pull out those plastic mats. And everyone just passes out. But I would always be like, I'm not tired. And they'd be like, lay down, don't make a noise. I swear the teacher would go to sleep too. Doesn't seem like good. I don't know. Watching over kids. We're all taking a nap. Me too. Stats will nap time. Be interesting. There we go. Class in 22 minutes. This is good nap music right here. That's what chat's saying. Okay, let's see. Investment website, phone survey, bank loans. Which one have we not done in a while? Let's do nearsighted. Philanthropy. School referendum we just did today. Bank loans. We've done bank loans a few times. New restaurant. Marketing research. Do we more? Marketing research. Yeah, marketing research is a quick one. We probably have time for 2 we do marketing research. Okay. Okay, let's take this question. Try to do 2 more. Now take a quick break, couple of food. Here we go. Marketing research. Let's go. Okay, this is the marketing research question. And a company is going to go out and survey 157 people. And they're going to find the proportion of customers who are likely to switch when their contract expires is this. So they find this. Now, I got problems with this question on the first part because we're assuming that that is the truth. This is probably where people get confused. They should have said this is the truth, because if they want you to find the standard deviation of the sampling distribution, the formula for it is you'd have to have the information P times Q over N square root of the whole thing. So that's what this is right here. And they are assuming, and I don't agree with this problem, you have to do it though, that this is equal to P. Now, if P is equal to 0.17, then Q is equal to 0.83. And at this point, it becomes plug the numbers into the formula right here. And we would, oops, did I hit the wrong button? I didn't. Oh, was I not even here the whole time? I think I hit it twice then. We would plug in the numbers right here, 0.17 times 0.83, put over to the sample size. Sample size is right there. So sample size is N, and 157 square root. And let's go ahead and try it. 0.17 times 0.83. There we go. Oh, cool. It's basically 0.03. Cool. 0.03. Is that all going to round? Nice and purdy right there. So that is 0.0300. Maybe. It's close enough, right? Oh, well. Let me look at the answer. Let's check it. Oh, it's not. Because it... My brain is just forgetting how to round. Well, to round the whole thing up. Ooh. A few people have emailed me. I think it's going to round the whole thing up. See, if I want to cheat, what I'd do is I'd go over here to R, and good to see you here, Mitzi. I'm on the screen here. I'd go over here to R, drop it in, and go round to 4 decimals, and there it is. So that does confirm the answer. My brain is working properly. But the last question right here says, if they want to reduce the standard deviation by half, what would they do? This is a theory question right here, and it goes to the formula again, though. When we do P times Q over N square root, if we want it to be half of this, well, what would happen to it mathematically? You can't just take this and put it inside of there. What you would need to do is you'd need to re-express this, but write it a different way. As in, this is still 1/2. Because if you write it, or maybe it'll make more sense if I do it the following way, because square root of 2 squared is 2, so that's just 2. I mean, it's a weird way of writing it. But the reason to write it this way is that you can now include it in the radical. So you'd rewrite it that way as 2 squared square root of that value, because it's still just 2. These things literally cancel each other out, and then square root of 1 is just 1. So still the same thing. With that in mind, we can put it in the radical right here and do n 2 squared over pq. Yeah, it is. Sure. So what does this mean? Well, this means the answer to the question is not to take 2 times the sample size, but 4 times the sample size, because 2 squared. And so all we have to do right here is take the sample they gave us to reduce the standard deviation by half, is go 157 times 4, and there's the answer. Yay! A little bit tricky. Theory question. You have to exponentially increase your sample size to decrease your standard deviation by a certain factor. Trying to think of a time for another quick one. We'll speed run one. Investment web. So we haven't done investment website. Okay, let's just add in quick here. I haven't done this one lately, so this is a really good one. Okay, so investment websites. 121.04. There we go. So with the investment websites, what we're looking at right here is an investment website tells what devices customers are using. The site managers would wonder they should enhance facilities for trading via smartphones because 32% of people use a smartphone, and they're going to take a sample of 144. This is N right here. This is the truth. If we meet the conditions, which are random, 10%, and success failure, the distribution will be unimodal symmetric normal. So it's normal. It should just say normal there. What is the mean of the distribution? The mean of the distribution is what we would expect to see, which is the truth. And there's the truth. And the standard deviation of the distribution would be P times Q. Ooh, yes. P times Q over N square root. And that's the standard deviation of the distribution. I think round up. Round up. Yay! Well, that's got it. We got a good bit done during office hours today. I'm going to go grab a little bit of food here real quick. We'll be back next weekend. This weekend, I need to send out some announcements. Until then, bye for now, everyone. Unless you're in 320, I'll be seeing you in 320 soon. Enchiladas. That'd be awesome. Bye, everybody. Bye.